that angle, as a scientist, what we done in earlier, what we are going for in future. So today, my basic is the topic is electrochemistry. This is just a branch of chemistry, a small portion called electrochemistry, coming under physical chemistry. So if you want anything clean, that is you want clean energy, or you want clean water, or you want clean air, so everything will come under electrochemistry. That's why I'm given the topic electrochemistry for people and planet centric. So if you read the completely the electrochemistry, you can understand that it is definitely that it is a centric for the people and the planet. So before going to that my lecture, you can see that where India is placed all over the world. You can see that. So in the middle, so India is in the middle of the mark. You can see that it is a point 0.6. So how this was characterized before going to science, where India is there and where we have to go. We have to achieve the number one. So still we have to go very long way to achieve the Vikshit Bharat, or I can say that Human Development Index should be one. So you can see the United States, the human index is zero point 0.9. Still we are in so much population, we are in zero point 0.6. As a student, you have to think a lot what we can to do for zero point 0.9. So this is the way every country was given the rank where is the country is. So how they are calculating is, you can see that the graph, health, economy, and equity and education. These are all the marks they will calculate where is your country. You can see in India, it is, you can see the India and you can compare the US. You can see it is definitely it is a zero point 0.9. You can see India is zero point 0.6. It is little bit higher in the case of spending on education, but you can see the literacy rate is very low comparing with United States. By this way, the countries will be judged where is India like that. So you can see that the next one, funding, the people will always ask the funding. I am sure that India is given now 0.664% of GDP and the US is giving 3.45% of GDP for spending the R&D. But we can see that 60% of the world vaccines are produced in this country, even though it is a less, but we are the no number one in the vaccine development. So the next is, we can see the from degree to PhD where we are. We can see the China and India and USA. We can see the Indian, the graduates and doing the PhD is more than US and China. So this will given the very happy news that India is after the graduate number of PhDs are more in the case of India and other countries. So this is the publication performance. As such, India is a little bit high. That is 71% of the publications are cited by the others. These are all the good news for India. And this topic is mostly on the not in the science. So this is basically on the technology. So whatever the technology we want, India want technology rather than the science. You can see this is a long-term timeline for the technology. How the technology was came out. You can see that 3.4 million years ago, the first tool was used. So this is going on, the technology is going on rapid. Now we are in 2024, we are talking about the climate risk and clean age. For example, you can see the history of communication. So from writing to paper, to the printing press, to the telegraph and telephone, the radio, and all the way to internet and the smartphone. So this is the graph showing how the technology is going on. So you have to think of how the technology is going from the earlier days. and it is very, very difficult for the technology development. You can see that across the valley of tech from fundamental to applied research and technology. This is the academic research what everybody is doing. But you want the industrial research, you have to cross this valley of tech. It is very, very difficult to get the industrial research or you can get the technology. So this is the situation the youngsters can see that how you can cross this valley of tech to the industrial research. Now you can see that people are talking the climate risk. Because of climate risk, what we are going to do, whether the electrochemistry will do anything on the climate risk. What are all the things it is going to be happen if the climate changes? It is a extreme weather and species damage and water availability and people and you can see the Arctic sea level. So many things will happen when the climate will be changed. For that only we have to reduce the 1.5 degrees centigrade versus 2 degrees centigrade in the climate change. So why this climate change is happening is the CO2 concentration increases in the atmosphere. You can see that in the year 1000 to 2000 it is a huge increase, that is 50% of the CO2 is increased in the atmosphere. That's why the climate change will be takes place. So you can see that 22, 23 and 24, the carbon dioxide emission will be going on increasing. So if it is increases, definitely the climate change will be takes place and you can get the consequences. So by the way, the temperature also increases. So the temperature increases from you can reach you can see 1.2 1.3 degrees centigrade rise. So if the temperature rises, the sea level temperature, the surface temperature will be rises. If the surface temperature rises, you can get an atmospheric river in the atmosphere. What will happen if the sea temperature is excess? You can see that the CO2 is a greenhouse gas having life of 300 years of average. If you have to emit the CO2, the life is 300 years. Even your third generation will be affected. That's why the India is in the climate change. People are talking more about the CO2 in the atmosphere. So we have to stop the temperature rise from 1.5 degrees centigrade. So in 2024, the temperature rise is 1.56 degrees centigrade. It will giving the along that, so the world is getting warm. So this should be avoided by the CO2 emission. So you can see that how much time is left. It is going on. The rate of carbon emission is 14 lakh kg per second. So we have to control this much of CO2 in the atmosphere. So if we atmospheric river. So why what will the atmospheric river? You may be seeing that last week Vilpuram and Tiruvannamalai, because of this formation of atmospheric river, so the sudden rainfall in a particular place. So these atmospheric rivers happen all over the world, and because of the world warms, the atmospheric river can hold more moisture, which will lead to rainer atmosphere very heavily. So we have to avoid this type of atmospheric river formation in the atmosphere. So because of that, naturally the flood will be rises. You can see that 1970 to 79, this only 313 flood. You can see the 2010 and 19, almost 1393 floods are came because of the temperature rise of CO2. This is the present situation because of the climate change. Everywhere the flood is happening and the forest fire also increases because of the climate change and the ice melting at Antarctica regions and also the sea level rise rate is 3.4 mm per year because of the warming. So you can see that the 102.5 mm since 1993 in the Odisha, the rise sea level will be raised. And this is Antarctica region where you can see the temperature is going on rises because of the CO2. So there is a climate plan. If you see that in the website, India formed a climate club. So you can observe now the India is higher education ministry is insisting that every institution we have to keep this climate club to observe. People will see awareness how much CO2 is coming out. Suppose if you go for this red, this business as usual. Suppose you are not taking any action, whatever the CO2 will coming out, definitely it will create the temperature rise and the emission will be more. Suppose if you take a small size of investment, that there is a small decrease in temperature and emission also decreases. And if you take severe action, the temperature definitely will come out and the emission also come out. So this will give a climate flag. If you see our institution CSRC CREEP, we have kept the climate flag to alarm the school students and also the college students. So you can see the India is where it is. So they are given the mark, no? Here they are given how all the countries is performing this type of things. So India is coming here only 4.5 something. So these are all the marks given by carbon emission and the energy transition and green society and clean innovation and climate policy. So based on these things, the world is given marks. Even India is in the center point. We have to take many steps to achieve number one in this climate change. So you can see in the 50, the position of India is 50. We have to achieve number one. For that, we have to take many R&D research. As I am requesting all the students, don't take easy steps for your PhD research work. It won't work out for the long time. So you have to take the PhD work at the innovation thing. Otherwise it is difficult to make you as a job in your future. So that's why India is given the India's Panchamikra Tattva because the Prime Minister Modi is given the 5 points to achieve this type of things. So here I am going to touch up only the carbon emission and the energy in the case of hydrogen and also little bit water. So in the case of CO2, where it is coming means it is coming from thermal power and biogas and blast furnace and automobile. So these are all the main sources of CO2 coming out from the atmosphere. So how to reduce this CO2 from this source? What is the research is going on in our secret? So we make a nano material based on the silica. So this will absorb only CO2 rather than any other impurity present in the air, that is nitrogen or atmosphere, whatever the thing available. We can selectively, it will remove only CO2 rather than any other material. So the DOE target is around 1.4 to 5 millimolar per gram. If you synthesize the material has to absorb 2.5 millimolar per gram. If it is the material absorb that much concentration of CO2, you can transfer to the technology. We are assured that the material it will absorb around 3.43 millimoles of carbon dioxide per gram. We are tested in selectivity and absorption kinetics. You can see very fast absorption kinetics. It won't take time to absorb the CO2. So this is the material we develop and CSR secret, and also this was transferred to immediately to the industry to make a successful to remove CO2 from the all the sources, thermal plant, whatever the thing you need, you can get pure gas to the atmosphere. I don't know this. This video is a small video. By 2030, India will reduce the carbon intensity of its economy by less than 45%. So by the year 2070, we have zero CO2 to the atmosphere. So this we are trying to summits. We are trying to based campaigning. So now they are making the trials in different places with our know-how and technology. So this is the industry where our technology is going to be main part in all over India. You see the industry is emitting the flue gas, and we are capturing this flue gas. This is a capturing plant where we are keeping our innovative powder. This is a two-step. One is absorbing, one is deabsorbing. See that nitrogen and the CO2 is coming from the flue gas, and it will absorb only CO2. So now we can get the CO2 free flue gas. And once it was saturated, so with our air will be regenerated, and it will with our we will be take care of that flue gas emission. So now it is a pilot plant. Designing and manufacturing is going on. So the first installation will be going on in the NTPC thermal power plant. Like that, it will.
Visual sir.
So here only the electrochemistry play. So once you are absorbed, what you are going to do with CO2. So using this electrochemistry, you can make all the CO2 to ethanol or methanol or alcohol, whatever you want. You can reduce that CO2 to the very useful fuels, where the electrochemistry will play a vital role. So the students, please take this type of project for the India. So India need many fuels like this. So we have the plenty of CO2. We want the research oriented this type of e-fuels for India. So then only we can go for big ship at 2047. So next is after the CO2, we have to think of our green or renewable energy. We have many electrochemical system or sustainable system for the sustainable world. So we have the chemical energy storage and also the thermal energy storage. Many energy storage devices are there for our future. So today I am going to talk about later on the hydrogen energy based system, where it will be work, how it is green. So you can see that renewable means the challenges are more because of the sunlight only. The solar will work, and in the wind is very intermittent. And in the case of battery, we have to think how big and how capacity, how long discharge duration. There are so many questions will arises. So I am say that hydrogen is the magic green fuel in the future, and you can see that. So now there is no oil. All the energy sources are no. It is a burial ground where the oil will be buried. So it was predicted in 1956. You can see the oil age is going on decreasing. The hydrogen age will be started. So this was predicted in 1956. It is now true where hydrogen is taking place in everywhere. So you can see that no, there is a liquid gas is coming down and gaseous is starting. So this is the graph. You can see that only the gaseous fuels will be in the future. You can see earlier the competition between the batteries and fuel cells. Now the competition is the fossil fuel cell batteries, and hydrogen is beating these two fuels. So why I am making the hydrogen? No, it is we can see the gravimetric energy density is more in the case of hydrogen, and in the case of volumetric energy density, comparing with batteries, the liquid hydrogen will be the more. That's why now people are talking more about the hydrogen, and this is here multifunctional. Wherever you want, you can use this hydrogen energy. In the case of battery, it is very difficult to use many places. In the case of hydrogen, you can use of energy source or industry or transport. That's why I'm telling that hydrogen is a multifunctional energy to work on this in many fields of hydrogen energy. So that's why the India's green hydrogen mission was started by our Prime Minister of India and worth rupees almost 18,000 crores for hydrogen only for the next 5 years. And you can see that there is a many colors are given for the hydrogen. The green is one, you can get the very high pure hydrogen. How I'm telling is you can see you can prepare the hydrogen in the many way, but everywhere the CCS is required. But in the case of electrolysis, there is no carbon capture is required. That's why the electrolysis is a main process. Now people are talking about the hydrogen production. There are many method of production methods are available for green hydrogen. For example, I can say alkaline, PEM electrolyzer, solid oxide electrolyzer. The many research is going on, and this is no. You can make the hydrogen with electricity from renewable. There are many sources. You can see the biological, electrochemical, photochemical. There are many systems are available for the production of hydrogen without electricity from the renewable. Even the biologist can do, or chemist, physicist, everybody can do the green hydrogen without electricity or renewable. But if you want the electricity, you can make use of hydropower, wind power, biopower for the green hydrogen generation. You can see this is the a typical graph of PM electrolyzer. You can just go through the PM electrolyzer in the literature. You can get many pictures over that. So this is the first prototype made by Sikri, and this is the second prototype. It is a little bit more, and this is the third prototype, and this is the fourth. And now the research is going on, and we have developed we had 2000, 3000, 4000, and 5000, 6000 meter cube of hydrogen. Now we are planning for the 20 to 25 nm cube of hydrogen for the usage of in many places. Technically, you can see it was very competent with the international. And as CO2, we are also transferred the technology to the Eastern electrolyzer. They have started manufacturing and implementing in the many industries. This is a wonderful technology. Say that India's first technology in the electrolyzer in the case of green hydrogen, and we are now making use of this solar. And there are many competition or many things is going on to get the target of 2050. And we are the CSR Sikri is the one of the competitor for the all over the world. So these are all the multidisciplinary system we need. So you can even chemical engineers or mechanical, everybody want this electrolyzer system. And the next one is alkaline. Here also we made 5 kilowatt electrolyzer. It is going to be transferred in many places. And this is the high temperature electrolysis. Still we are not working in this. And it is here also we need more attention to the many disciplines. We can see we have started this electrolyzer research in 1996. So each and every year we are going on progressing. And now in 2030 our target is almost 20 to 50 nm cube or 100 nm cube, like that. Our progress is completely going towards the Vikshit Bharat, and we are also making the seawater electrolysis of hydrogen, and many more methods are we are doing in the hydrogen generation. And also there is a many we have to be more careful because of the hydrogen. There are many accidents are happening all over the world. So we have to the safety norms will be given very much. So these are all an ultimate goal for all over the world. And this is all in the demand. How much demand? As I can see, you can see that demand of hydrogen will be going on increases, and you can see the India and many countries the demand for hydrogen is going on increases. Now you can see that Niagara Falls to integrate the hydrogen center. You can see that Niagara is only the you can see the falls, but now they are integrating the falls into the hydrogen generating system. So the India is started making the hydrogen based railway system. Already the things have started with the Kalka and the Shimla route. So everything the Sikri is going to take part in these railway lines. And you can see every places the hydrogen is going on started, and the world commercial fuel cell train started, and 1,600 kilometer longest route of lorries transported started in China, and the zero area vision is started doing the hydrogen based aircrafts. You can see the Berlin started the complete hydrogen-based airport. So India is also going plan for this type of systems, and hydrogen-powered house is going on in France. So these are all the things you can see that. If you cost-wise, you can see in 2050 the cost is very cheap. Even though you can think that now it is costly, but in 2050 almost it is equivalent to the price of petrol. So these are all the graphs where the uses, the challenges in cement industry is a challenge in hydrogen, and ammonia industry having the challenge in hydrogen, and also the steel industry. So many places this type of hydrogen demand is going on. So now the hydrogen valley is started, and we are also doing the some fuel cell research. Uh, you can see in the environmental point of view, I can say that hydrogen also giving the warming effect because of it will react with the OH, it will give the methane and it will create the O3. Apart from CO2, hydrogen also giving the warming effect. So we should be more careful on that, this type of things. So with respect to pure water, you can see that where the electrochemistry will give the very clean process because it is a environmentally compatibility electron giving. It is a more flexible and more selective. So the electrochemistry will play green air and clean air, and also the green energy and also the green water. So wherever you can use the electrochemistry, so you can see that many places electro oxidation technologies you can do the very clean process for the water, and we have the technology for the defluoridation. So this technology was transferred to almost 10 to 12 industries now implementing this type of electrochemical removal of fluoride from the drinking water, and also we developed electrochemical removal of arsenic from drinking water. So this is a demo, and we have transferred many industries. So like that, we made the removal of arsenic by electrochemical route, that is called electrocoagulation, and also we developed nitrate. You can see India is the, very much agricultural country. This is also happening through the electrochemistry. This is done by Indo-French project. This is also transferred to one industry in France. This is the system of hypochlorite. This is the ozone generator, and this is the combined one. And we are also now started the electrochemical water desalination technique to replace the RO system in a cheap rate. And you can see that the hydrogen is not only for the energy, this is also for the antioxidant rich water. If you take the hydrogen dissolved water, it is a very high antioxidant water. We have the technology for that. So if you take this type of water, your anti-aging will be takes place in the hydrogenated water. And finally, you can see where the electrochemistry play is in ammonium perchlorate. Without electrochemistry, we can't do for the ammonium perchlorate. Still, ISRO is using the first stage propellant as the ammonium perchlorate. So there are many technologies based on the electrochemical technology we use. And dear student, this is for you. A student who got 3.8 CGPA is unhappy because another student got 4 CGPA. And the student with the 4 CGPA is unhappy because he is not placed in a core company. And student placed in a core company is unhappy because his colleague has more salary than him. The person having the highest salary in a company is unhappy because he or she has no time to all enjoy the family life. So this is what happens when you get trapped in the infinite rat race. So you are never happy and you will never appreciate or be grateful for the life for you. So come out of this type of rat race and start thinking independently and start doing the research independently and start doing the job independently and you can start the startup company. Don't go for this type of rat race in future. You can be trapped. Definitely you can be trapped. But thinking will be always independent. You should be unique in all the places. So this is the message I want to give for the student. So you can see the history, it is a nursing one. So as Hiranya want his death to be the following way that not to be killed by any man or animal, not in air, water, sea, fire or land, not in some coma outside, not at the day or the night. And all these situations he tackled. Finally he killed Hiranya in his own thought. So you have to be think differently, then only you can achieve anything. Thank you very much.
Thank you, sir. A short valedictory program. Now I would like to invite HOD of Physics Department to honor the guest. A short valedictory program is about to begin. The program would take about 15 minutes and I request all the audience to be seated with patience. Now we will be paying tribute to the masterminds who have shaped our destiny.
Ladies and gentlemen, as we are nearing the end of this amazing conference, to bid a proper farewell, let's welcome Dr. Anita, Associate Professor, Department of Physics, to give the welcome address. I welcome the dignitaries on the dais.
It is with great pleasure and honor that I welcome you all. It is with a great pleasure and honor that I welcome you all for this validity program of International Conference on Frontiers in Science and Technology, Energy, Environment and Sustainable Development. Today, we gathered here to celebrate and explore the cutting-edge innovation and research that will shape the future of our planet and society. I feel immense pleasure in welcoming Dr. S. Vasudevan, a visionary scientist whose work at CSIR Karikudi continues to inspire generations. Welcome you, sir. It's a great honor to welcome our guest of honor, Dr. H.C. Anandamurthy, sir, Professor in Applied Science, Papua New Guinea University of Technology. Welcome you, sir. I take this opportunity to express my sincere gratitude to our Dean Research, Principal, Vice Principal for being guiding a light and constant source of encouragement to us all the time. Welcome you, sir. It's my pleasure to welcome our convener, Dr. K. Shakti Pandi, whose hard work and dedication ensure the smooth execution of our conference. It's my honor to welcome Dr. P. Sevuraman, HOD Physics, for fostering a culture of innovation and excellence in research within our institution. I extend my hearty welcome to coordinators of Science and Humanities, HODs, and faculty members, my dear colleagues, and research scholars from SRM and various institutions for being with us in this grand occasion. Once again, I welcome you all.
As we bring this momentous occasion to close, This international conference will leave us with a lasting impression. It is my honor to introduce Dr. Vishweshwaran, who will now share his insightful concluding remarks. Blend of reflection and vision.
Good evening. The conference on Frontiers in Material Science and Technology, which is a hybrid format with both in-person and virtual session, making it accessible to a wider audience. The inaugural event took place in this hall with about 150 attendees, all passionate about pursuing the boundaries of material science. This event brought together the leading expertise, researchers, and industry personnel to explore the latest advancements and challenges in the rapidly evolving field of material science. Over the course of the event, the participants engaged in vibrant discussion on cutting-edge course of events, technologies, breakthrough materials, and transformative potential across various sectors, including energy, environment, and sustainable development. The discussion over past days have highlighted the immense potential of new material in diverse applications, from energy to healthcare, and have pointed to a need for continued interdisciplinary collaboration, innovation, and research. It is with joy to present to you the research response from all sectors such as academia, industry, and research institute. Nearly 400 articles have been received, of which 290 articles were accepted for presentation. And which uh, we have this discussion held in 8 different platforms in 18 sessions, of which 290 articles were accepted for the presentation. It is proud that this conference has brought 53 young women scientists to present their emphasize on the importance of gender diversity, which is one among 17 SDG goals that promoted leading women researchers to share their innovation. And this conference also addressed the other SDG goals, such as clean water and sanitation, of which 22% of articles were under this domain, 54% of articles were under affordable and clean energy, and 24% from industry, innovation, and infrastructure domain. Based on the inequality of rewards, 15 presenters were selected for the Best Paper Award, which is to be announced shortly. We look forward to seeing the transformative impact and technologies shared at this event in the coming years. We thank all participants for their contribution. Thank you.
Now, I gladly Chief Guest Dr. H.C. Ananthamurthy to talk a few words as valedictory address. Due to the time constraints, I kindly request you to make it short, sir.
Respected dignitaries on the dais, my dear students, staff of SRMTRP, research scholars, and all the participants. First, I wish to congratulate the organizing committee for successfully organizing this conference. A special thanks to all the researchers who have presented papers, the session chairs, the professors who have delivered the enlightened talk to the researchers. It's a great occasion to share this information to all the researchers. So this is a conference, is a platform where there is a culmination of great resource people and students on the other side. So I think this conference has helped our researchers, young students to learn new things. So in a closing remark, I wish to appreciate the entire team of SRMTRP for organizing such an international conference, to the students and other participants from various places. So it's a great success. So finally, I wish and I like you to join with me in a way that we appreciate all the organizers with a great applause for the great success of this conference. Thank you very much for giving me this opportunity. I hope that the SRMTRP keep continuing this kind of conferences every now and then to benefit the researchers. Thank you very much.
Thank you, sir. Now I kindly invite the Dean Research, Dr. Krishnamurthy, to give a short felicitation address.
Good evening to all. I've been thanked for the opportunity given to me, and I will be promising that I will be keeping up my words in a minute or so. At the outset, let me thank the convener as well as the entire team of Physics Department of SRMTR Engineering College for having done a wonderful job. Actually, this is a culmination and interface between the researchers, students, and other organizations, industry, likewise they have done. I'm sure that all the delegates have enjoyed the great benefits out of this. I'm also happy to note that our own students are also benefited out of this. What I request to every one of you is this should be extended further. Students, please try to understand how it has been done, how the people are doing the research. Those who are already doing the research, please see that how best you can do it. Those who are already completed, let us take a part and take it to the society in terms of patents and other things. Right? Likewise, it should grow. With this aspect, I thank the opportunity and I'm sure that this is a wonderful session that we had. In case if you have any feedback, please leave it us so that it can be taken as the next chance we will be able to do all these things that we are not able to do it. With these few words, let me thank all of you and wish you all the best. Thank you.
Thank you so much, sir. As we are nearing the climax of our conference, it's time to recognize and award the outstanding research and academic excellence among our participants. Let's move on to the Best Paper Award presentation. I gladly invite Dr. A. Joseph Sagaya Kennedy, Assistant Professor for Award Distribution, and I request the dignitaries to distribute the awards.
Good evening. Let's start with the Tirukkural. தெய்வத்தால் ஆகாதெனினும் முயற்சிதான் மெய்வருத்த கூலிகள். It's with the great honor that we award the best paper for the authors for their insightful papers in ICMFC 2024. The juries were particularly impressed by the paper's innovative approach and potential for advancing our knowledge. Please join us in congratulating the following authors. So totally 15 actually, 15 best paper awards in ICMFC 2024. So physically present participants today kindly come and collect the award. Right? Ms. Tejaswini DM, Department of Studies, Chemistry, Jawaharlal University. Okay. Okay, somebody is from the university. Another participant from the university. Okay, maybe an online participant. Ms. Theresa C, Department of Physics, Tyagarajar College of Engineering. Mr. Bharatkumar SP, Department of Chemistry, JSS Science and Technology University. Please give a round of applause. Yeah. Mrs. M. Darshini, PG and Research Department of Physics, AVVM Sri Pushpam College. Okay. Ms. Veda R, Department of Physics, PM College of Engineering. Sir Anil Kumar Sarma, Center for Renewable Energy, VBSB University, Jaunpur. Mr. Vijay Kumar CJ, Department of Studies in Physics, Dhawanri University. Miss Dharani, Department of Physics, Holy Cross College. Mr. Vishu, PG and Research Department of Chemistry, and the Hans Rover College. Dr. V. Aravindan, Department of Physics, Tyagarajar College of Engineering. Dr. Murugeshan A, Department of Chemistry, SSN College of Engineering. Dr. A. Nisara Begum, Department of Naikar College. Anybody from?
Please make a big round of applause.
Dr. Shita Lakshmi, Department of Physics, Shita Lakshmi Ramaswamy College. Dr. Pushothaman KK, in his absence, I call upon Dr. B. Sedraman, Head Department of Physics, SRMTRP Engineering College. Professor Manimaran S, Department of Civil Engineering, SRMTRP Engineering College. Thank you.
Thank you, sir. Let's take a moment to acknowledge the efforts of everyone who made this event a resounding success. Before we part ways, I would like to invite Mr. G. Purushothaman to express our heartfelt gratitude with a vote of thanks. Please, sir.
Good evening to one and all gathered here. It's
I request the students. I request the participants to give a short feedback on the conference.
I'm Anusha. I'm first year research scholar from JSS University Technology, Mysore. I really had a great experience here. This is my first conference I have attended. I have got a lot of experience here, like lecture professors used to share knowledge, even if this is a conference. So in hostel, the every arrangement they have made, it is really great. I like hostel environment is also very good, and the facilities they have given is really good. So thank you.
Good evening to uh, good evening to everyone gathered here. It's my privilege to deliver the vote of thanks for this international conference organized by the Business Department as TRP Engineering College. First and foremost, I express my heartfelt gratitude to our chief guest and the distinguished speakers for the gracious presence. I extend sincere thanks to the management, principal, dean research, vice principal, HODs, and the faculties of TRP Engineering College for the constant support and encouragement this event as a great grand success. A special thank you for organizing committee and faculty members of the dedication and hard work in planning and executing this event seamlessly. To our students and volunteers, your enthusiasm and commitment behind these scenes have been remarkable. You have played a crucial ensuring the smooth conduct for the conference. I also thank the delegates and the participants and the attendees from across the globe for their active participation and engaging discussions. Your presence has made this event more meaningful. Lastly, I extend my gratitude to our sponsors and partners for their gracious support in making this conference possible. As we conclude, let us carry forward the learnings and inspiration from this event to drive progress in innovations in physics. Thank you, one and all. Have a safe journey back. Thank you.
Thank you, sir. Participants, refreshment is arranged outside. You can take the refreshment.
Certificates can be collected from the registration desk. Certificates can be collected from the registration desk. Okay, refreshment has been arranged. To go and have a refreshment and collect the certificates. And thanks for coming and joining us. Thank you so much.
யாரும் இல்லை, நீங்களும் நினைச்சிருங்க